Our third and final conic section that we're going to be talking about is the parabola. And you can see in this upper right image that the way we define a parabola is having equal distance from a fixed point, which is the focus, and a line, which is our directrix. So those different lines are all the same length from either the focus or from the directrix. Kind of like how with our ellipses, the distance from the two foci, if you add those up, that's a constant. But again, this is a conic section, so if we slice a cone in a certain way, we're going to get a parabola. And we've seen parabolas before, but we're going to see a slightly different way of formatting our equation. So we'll see what that looks like on the next slide. But we're going to talk about this new term called the directrix. And the vertex, instead of having two vertices like we had with ellipses and hyperbolas, we only have one vertex because we really only have one piece of our curve, or one branch, instead of like hyperbolas had two branches. So let's start by looking at our general equation. On the left-hand side, these are both parabolas with a horizontal axis. So this is our axis. And on the right-hand side, that's a vertical axis. We can label, to start off, our vertex. We're going to label that as HK. And I'll just label the rest of these with a V. So that's basically the kind of point where the curve changes from one direction to the other. So there's our vertex. Now we have a term that we use called P, and that's the distance from either the vertex to the focus or from the vertex to the directrix. So those distances are P. P can be either positive or negative. So for these top two, where we're opening to the right or opening up, those are both values of P greater than 0. And for the bottom two parabolas, those are P less than 0, opening to the left or opening downward. And finally, we can label our focus. In our focus, I'll label that with F. Our focus, we said, is the distance of P away from our vertex. So in this case, for our horizontal parabola, we would do H plus P to get our new X value, and it still has a Y value of K. In our right-hand example, where we're opening upward, if our vertex is HK, then we're adding P to our Y value instead. So our focus would be H comma K plus P. And the last thing that we can label is our directrix. So our directrix is this vertical line outside, away from our parabola. Unless you have a vertical axis, then it's the horizontal line. So these are our directrix. And this line, like we said, is a distance of P away from the vertex. Vertical lines are always x equals, so the equation of the directrix in our first example is x equals h minus p. So we shifted to the left by p, so I subtract p. Now on this example to the right, our directrix is below our vertex. A horizontal line is always y equals. So we started our k value, and again we're going to subtract p, k minus p. Now to label the other two diagrams, you can go through the same process of kind of reasoning through what everything would be, or I would just recommend to go to page 736 of your textbook. That has a really nice diagram with all four of them labeled very neatly. So we're going to use these to help us with some examples, but first we're going to go through the definitions. Like I said at the beginning, a parabola is a set of all points in a plane that are equidistant from a fixed line, and the line is what we call our directrix. and from a fixed point, which we call the focus. Parabolas are a little different because we only have one focus, we only have one vertex. Our axis is the line that cuts our parabola in half, and it cuts it in half symmetrically, passing through the vertex. It also passes through the focus, which we'll talk about a little bit later. Now our vertex is the point on the parabola that's equidistant from both the directrix and the focus. Like we said, P in either direction. So our directrix is a line perpendicular to the axis, located at a distance of P from the vertex. And our focus is a fixed point along the axis, located inside the parabola, also a distance of P from our vertex. So those definitions will help us as we're working through some examples. Okay, example 1. We're given an equation of a parabola, and we're asked to identify various information, the vertex, focus, and directrix. Then we need to provide a graph. So my vertex, similarly to circles and ellipses and hyperbolas, will be our HK value. So that's -3, 1. In order to find what our focus and directrix and our graph looks like, we need that p-value because it really helps us put everything together. So I'm going to take this value of 8, and I'm going to set 4p equal to 8. Because if you notice in your equations on the first slide, we have y minus k squared equals 4p times x minus h. So whatever number is multiplying our x minus h, that's equal to 4p. So this gives us a value of p equals 2. So the focus and the directrix are a distance of 2 away from that vertex. So next I'm going to plot the vertex. Go -3, 1. And real quick, because we have y squared and our p-value is greater than 0, that's going to look like our first graph, which is opening to the right. So in general, that's what the shape we're looking for is. So if this is my vertex, I know that my focus is to the right along that axis, a distance of 2, since p is 2. So there's my focus. And my directrix is a distance of 2 in the other direction, to the left, and it would be a vertical line along x equals -4, or I'm sorry, 1, 2, 3, 4, 5. X equals -5. Okay, so x equals -5. Our coordinate for our focus we can find off of our graph would be -1, 1. And to provide a more accurate curve, I want to find one point. So what I'm going to do is I'm going to plug in x equals -1, since that's the value of my focus. So that's going to give me y minus 1 squared equals 8 times -1 plus 3. Y minus 1 squared equals 16. If I take the square root, that's going to give me y minus 1 equals plus or minus 4. So I get the y values of 5 and -3. So I'm going to plot those extra points. -1, 5, and -1, -3. And my parabola should make a nice curve through those 3 points. And there you go. That's all you need. So we found our focus, -1, 1. We found our directrix, x equals -5. And we already found our vertex at the top. Similar process for example 2. This time we have x squared. So it's going to either be opening up or down? Because 4p is equal to -4, we know p is equal to -1. So since p is less than 0, it opens down. So in general, I have something looking like that. We can identify our vertex, which would be 2, 3, and then we'll start to plot our information. So 2, 3 gives me my vertex. I know in this case my directrix is above, since my parabola opens down, opens below. And p is a value of 1, so it's 1 unit up would give me the directrix. So it's that horizontal line at y equals 4. My focus is 1 unit in the other direction, so 1 unit down would give me my focus. So really I'm taking 2 and I'm subtracting my p-value, so I get 2, 2 instead of 3 minus 1. And then to find one more point, this time I'm plugging in a value so I can get a more accurate point. So let's plug in y equals 2, since that's the value of the focus. And I'll extend the page here so we have a little more space to write. If we're plugging in y equals 2, we get x minus 2 squared minus 4 equals -4 times 2 minus 3. On the right-hand side, I get +4. On the left-hand side, I still have x minus 2 squared. So taking a square root gives me x minus 2 equals plus or minus 2. So x equals 2 plus or minus 2. That gives me 2 different x values, which is good. I'm going to get 4 and 0. So I can start to plot those 2 points on my graph. So if x is 4, y is 2. If x is 0, y is 2. And then I can make my parabola. Like so, opening downward. Okay, the next 2 examples, we're given certain information and we have to actually come up with the equation for the parabola. So our first example says find the equation of a parabola with vertex at the origin. So that tells me hk equals 0, 0. And we have a focus of -2, 0. So I thought it would help just to get a quick sketch to help us visualize. Our vertex is 0, 0, and our focus is -2, 0. That means my directrix must be on the opposite side of those 2 points. Okay? In general, the shape is going to look like that, opening to the left. There we go. Okay, so if we're opening to the left, and we have a horizontal axis, then my general equation, open left means that p is less than 0. It means that our y values are squared since there's 2 y values for any given x value. So it's y minus k squared equals 4p times x minus h. Because our focus is -2, 0, you can see that the difference between the center, or sorry, the vertex and the focus is 2. So p is equal to, in this case, because p is less than 0, p would be -2. So we're going to start to plug in our h, k, and our p value, and we'll get our equation. So h and k are both 0, so we would get y minus 0 squared equals 4 times -2 times x minus 0. And simplifying things a bit, we get y squared equals -8x. So there's our final equation for the parabola. Our next example is finding the equation given a focus and a directrix. So I'm going to plot those. I think it always helps to graph it. -1, 4 is the focus, And the directrix is a horizontal line, y equals -2. That's our focus. Now recall that our vertex is midpoint of vertex, of the focus. And the directrix. So if you count the number of units between the focus and the directrix, we would get 6. So halfway in between is a distance of 3 away. So the vertex from the graph is -1, 1. It opens up, so p is greater than 0. And we found that it's a distance of 3 units, so p is equal to 3. Since it's a horizontal directrix, that would make it a vertical axis. So a vertical axis always looks like x minus h squared equals 4p times y minus k. So we can plug in everything we know. We know that x plus 1 squared equals 4 times p would give me 12 times the quantity y minus 1. Notice about our two answers here. They are in factored form, where we have our squared term on one side and we have our other terms on the other side in factored form. So for our next two examples, we need to create that form of a parabola. So example 5, I'm going to complete the square, but only in terms of y. I'm going to move my 8x and my 8 to the other side. So completing the square with y, I get 2 times parentheses y squared plus 8y plus a blank. And since I move my 8x to the other side, it's positive 8x minus 8. And I have to add on 2 times whatever I fill in for my completing the square term. That's going to give me 8 over 2 squared, which is 16. So I'm adding on 32 to the right-hand side, 2 times 16. So putting it all together, I've got 2 times the quantity y plus 4 squared equals 8x. This is 32. Negative 8 plus 32 is going to give me plus 24. Looking at your general form for parabolas, I need my squared term to be isolated, so I'm going to divide everything by 2. And that's going to give me y plus 4 squared equals 4x plus 12. And finally, I need to factor the right-hand side. So that's going to give me y plus 4 squared equals 4 times the quantity x plus 3. From the equation, we can identify the vertex very easily. It'd be -3, -4. We know that 4p is equal to 4 in this case, so p is simply 1. Since our y terms are squared, we have 2 y values for any x value, so it's going to be opening to the right. So something like this. That means for my focus, my x value is changing by p, so I'm going to add 1 to my x value. I still have the same y value, so my focus is -2, -4. And my directrix, it's a vertical line we can see. Well, normally it's x equals our h value, but we're shifted because of our p value. We have to go back 1. So instead of x equals -3, we're subtracting 1 from that. So it's x equals -4. So we've got our vertex, we've got our focus, and we've got our directrix. So we're going to try one more of those examples and then leave you to try one on your own. So our last example, again, completing the square. This time we're going to complete the square in terms of x. So I have x squared minus 4x plus a blank is equal to negative 2y minus 10 plus whatever I fill in for that blank. So 4 over 2 squared is going to give me 4. That goes in my blank. And completing the square, I get x minus 2 squared equals negative 2y minus 6. This is almost there. We just need to factor the right-hand side. So x minus 2 squared equals negative 2 times y plus 3. And here we go. We're already in our standard form, so our vertex will be 2, negative 3. To find our p-value, we set 4p equal to negative 2 and solve. So we're going to get p equals negative 1/2. Since our x value is being squared, we know it's a vertical parabola. And because our p-value is less than 0, it's going to be a vertical parabola opening downward. So in general, that's our sketch. We know our vertex. So from that, to find our focus, we can see our focus is directly below the vertex. So the x value is still 2. The y value is negative 3 minus 1/2. It's 1/2 units below, which is going to give us 2, negative 7/2. And our directrix will just be 1/2 units above the vertex in this case, because it's opening downward. So it's going to be a horizontal line, y equals, starting at the y value of negative 3, and we're going up 1/2, adding that p-value. So y equals negative 5/2. I really think that it helps to draw a picture for these to visualize where the focus, directrix, and vertex are located with relation to one another. And then make sure you're just using those formulas on the first page really carefully, finding h and k appropriately, finding your p-value, and plotting what you know. So there's one problem for you to try. Go ahead and give that a shot, and that will wrap up chapter 10.